So this is the axon, and it carries the information away from the cell body and towards other cells. And then this is our synapse. Okay, the synapse is the gap that separates the neurons. And then this is the axon terminal, knob-like structures at the end of the neuron that carry the synaptic vesicles, which hold the neurotransmitters. These are the dendrites, which are branching extensions that receive messages and conduct impulses towards the cell body. And then these are the dendritic spines that protrude from the dendrites, and they receive input from a single axon at the synapse, and they're also storage for synaptic strength and help transmit electrical signals to the body. This is the soma, and it contains the nucleus, and then the nucleus is inside, and it directs manufactures of substances that neurons need for growth and maintenance. This is the myelin sheath, and this insulates the axons and increases velocity of conduction of action potential along the axons. These are the neurotransmitters, and the neurotransmitters transmit info across the synaptic gap to the next neuron. Here's the nodes of Ravier. This is the gaps in the myelin. It shows they're densely populated with sodium channels, and as the action potential reaches the nodes of Ranvier, the sodium channels open and cause the influx of sodium, which prevents the action potential from decaying. Okay, and then the presynaptic neuron is the neuron all over here, which is the neurons where is delivering the message across the synapse to the postsynaptic neuron, which is over here, and this is the receiver of the neurotransmitter message.
Okay, so the action potential occurs in the axon, and that is when a sense stimulates the nerves or the neuron receives a message from a previous neuron that wants to fire an impulse down the axon to the next neuron. Depolarization is when sodium rushes in the axon and potassium rushes out, making the neuron positive and ready to fire. Resting potential is when the axon is polarized, so there is potassium inside and sodium outside. The all or none principle is if the threshold of excitatory messages in the axon is met, the neuron will fire at the same strength and intensity the whole time. It doesn't change strength. And then reuptake is when the axon fires more neurotransmitters than needed for the neuron, so that to account for failure. And then the excess is absorbed back into the presynaptic neuron.